Dear students, in our last class we discussed about Dalton's atomic theory. Then we discussed about the subatomic particles present in an atom. And after that I have given you an assignment in which it was mentioned to write about the three subatomic particles. Okay. Now today we are going to do a very important experiment known by a name known as Rutherford's alpha scattering experiment. Okay. In this experiment, it has been tried to study by Rutherford to know the positions of electron and proton in an atom and lead to the discovery of a nucleus. Now what he has done is, in 1911 Rutherford conducted an experiment in order to find the arrangement of electrons and proton in an atom. In this experiment, a fast moving alpha particles alpha particle means the particles which are emitted from radioactive elements. Now that alpha particles are made to strike on a very thin gold foil of around 0.0004 centimeter thickness. Okay, now this is the arrangement. So this is a source of a radioactive element from which the alpha particles will come, and this is a lead plate. That means only through that hole that ray can pass. Now, and it is made to strike on the gold atom. Okay, now after that he observed the observations made by Rutherford on his experiment. He observed that most of the alpha particles continue their straight path like this, no deflection. Okay, and few alpha particles show deflection. You can see the deflection by making certain angles. Here also certain angles, here also certain angles, and very few were reflected back in the same direction as it has come. Okay, now on this deflection as well as undeflected alpha particles, he made some conclusion about the atoms. Since all the alpha particles continued the straight path, he has come to a conclusion that most of the space in an atom is empty. That's why the alpha particles continue the straight path, and very few alpha particle, that means when the alpha particles come near the atom, and we know that in atom at the center we have got the nucleus, and alpha particles are also positively charged. So when the positive charge comes in contact with the positively charged nucleus, since they are of same charge, they will show some deflection, certain angles. That means at the center of an atom there is some positive center or positive charge concentrated in it, and very few which are deflected back. That means that alpha particle has heated the atom, the nucleus directly. That's why, since they are positive and nucleus is also positive, they are completely reflected back. So this is the conclusion made by Rutherford in his experiment. Next we have after Rutherford, another Niels Bohr named scientist has come up with the development in the atomic theory or atomic model. According to his model, an electron revolves around the nucleus in a certain fixed circular path that we call orbits, or we call cells as well, and they are represented by later subscript as KLMN. That means if this is the nucleus, the first orbit will be k, then comes l, then comes m, n, and it goes on. So that was his arrangement of orbits. Okay, now after they also proposed that each orbit has a certain fixed amount of energy. They are called energy levels, and the orbit which is near to the nucleus, they have got the lower energy, and the energy and the orbit which are at the end, they have got the higher energy. Okay, so this comes from the Bohr's atomic model.